Dear learners, welcome to the second session on computation of mode. In the previous session, we understood what is the mode, what is the concept of mode, where the mode is suitable, applicable, how to identify the mode in individual series, and how to take out the mode from the discrete series through grouping table and analysis table. Now we are going to understand how to compute mode in continuous series. As you know, continuous series means there are some classes and frequency. You also know that classes may be constructed in inclusive classes or exclusive classes. Classes can be constructed in equal class intervals or unequal class intervals depending upon the data set. But whatever that may be, when the data is given to you, the first task for you to compute the continuous series is to ensure whether the data set is in equal class intervals or not. If it is not equal class intervals, then you have to make it as equal class intervals. This is another limitation of the what I can say locational averages, not arithmetical averages. Arithmetical averages, you can see if the data set is in unequal class intervals, you can continue, you can do it, you can use it. That is the reason this is the locational averages or positional averages. This is the limitation. Next, you have to follow the steps which we have followed in the discrete series, that is grouping table and analysis table. So that is the procedure, as I said in the previous also. This procedure you have to follow. Why you have to follow this procedure? In order to identify the model class to interpolation by using a suitable formula. Here also I am saying suitable formula. It should be kept in your mind. Why? Because one formula is not suitable to all sets of data depending upon the nature of data. We will go. I will explain what are the formulas available. So this is, now it is very clear that we have to ensure equal classes, otherwise we have to make it equal classes, and we have to prepare the grouping table, and we have to prepare the analysis table. Then we have to identify the value of mode lies in which class, and we have to apply the formula and interpolate and take out the exact value from the limits of the classes, upper limit and lower limit. Okay, now I will introduce the formulas for mode. Now you can see one formula, mode is equal to L plus delta 1 divided by delta 1 plus delta 2 into I. What is delta 1? Delta 1 is the F1 minus F0. Delta 2 is equal to F1 minus F2. Now I will try to explain what is the meaning of F1, F0, F2, L, I. These are the denotations. I will explain because these are repeating in the further formulas. Therefore, C, MO is mode, L means lower limit of the model class. F0 is frequency of the class preceding the model class. F1 is frequency of the model class. F2 is frequency of the class succeeding the model class. I is the class interval. Now we see the formulas. The second formula, mode is equal to L plus, previously also L plus, F1 minus F0. What is F1 minus F0? That is delta 1. Next, F1 minus F0. What is it? Delta 1 plus F1 minus F2. That is delta 2. This is expansion. If we simplify the second formula, the third formula is L1 plus F1 minus FO divided by 2F1 minus FO minus F2 into I. So, whenever you have been given the data, you apply this third formula only. Why I have given the delta 1 and delta 2, delta 2, sometimes you may have the short questions by giving the delta 1, delta 2, L and I for 5 marks to calculate the mode. For that you have to remember this also. Now if you see the fourth formula, there are big lines in between the F1 minus F0 as numerator. In the denominators also F1 minus FO, big two lines, two sides, plus these lines are termed as mode F1 minus F0. Here mode means ignoring the mathematical signs, plus or minus sign. Why? Sometimes the data, if you apply the third formula, the data may give the numerator or denominator negative value, minus value. If it is so, or sometimes zero value. If it is so, you cannot apply the third formula because there is no further meaningful calculation. Therefore, if there is any negative value arises, then you have to apply the fourth formula where the mathematical signs are ignored. Okay. Now we take up the illustration for better understanding. See, this is the illustration. Monthly rent paid. These are the values of the variates. The variants or items are number of families here. Now, what you have to do? First, you have to ensure the equal classes. Now you can see all classes are equal. Therefore, straight away you can go to prepare the grouping table and analysis table. This is the grouping table. Now I don't want to explain in detail. There is no need to explain in detail because already explained in detail while computing the mode in the discrete series. If you want detailed clarification, you can view here the previous session, that is computation of mode in discrete series. So here briefly I will tell, you have to first identify the highest frequency in column number 1, column number 2, add 2 to 2, identify highest frequency, column number 3, ignore first frequency, add 2 to 2, identify the highest frequency, in the column 4, add 333, highest frequency, and column 5, ignore the first frequency and start second frequency, add 333 and identify highest frequency, and column 6, ignore the two frequencies and add 333 clusters and highest frequency and encircle it. Here in the fifth column it was not encircled, but you have to identify which is the highest frequency. 45 is the highest frequency. So based on this grouping table, you have to prepare the analysis table. Now in the analysis table, 6 is the highest repetition. Number 6 is in higher. So its corresponding class is 100 to 120. So here 100 to 120 is the class. Now you cannot say that mode is the value in between 100 and below 120. So these classes are in exclusive class intervals. What is the exclusive class interval? 100 and above, less than 120. You cannot say like that. Mode is not can be expressed in the form of range. So you have to interpolate the value which lies in between 100 and below 120 through formula. That is the reason you have to interpolate by applying the formula. Now we are going to apply the formula. The model class is 100 to 120. That you have to remember. See, the model class is 120. Now you apply. What is L? L is lower limit of the model class, that is 100. Next, F1. What is F1? F1 is the frequency of the model class. Go to the frequency. What is the highest frequency? Model class frequency of the model class frequency, 100 to 120 frequency, 20. Okay, 20 we have taken. Now see the F0. What is F0? Frequency of the class preceding the model class. Now you go to the free data. What is the model class? 100 to 120. So frequency of the class preceding the model class. Preceding the model class is 100 to 120. So preceding is 80 to 100. So 80 to 100 frequency is 14. Now coming here, this is the 14. Now we want F2. What is the F2? Frequency of the class succeeding the model class. Model class is 100 to 120. Succeeding the class of the model class is 120 to 140. That is 15. Next, I is the class interval. What is the class interval? Class interval is 20. Okay. Here you can see class interval is 20. Apply the formula now. If you apply the formula, after calculation you will get 110.19. So 100.19 lies in between the model class. So this is the model value. Now we are going to take another example. This is the illustration 2. Now you can see the classes are given in inclusive classes, not exclusive classes. You know very well, you understood about the inclusive classes. Just I will repeat. 0 or more than 0, 9 and less than 9. That is the inclusive. And frequencies are given. Now let we go for grouping table. This is the grouping table. Again you have to follow the approach how to prepare the grouping table. Same, you have to identify first highest, then column number 2 highest by adding 2 to 2, column number 3 ignoring 1 and add 2 to 2 highest, column number 4 ignoring 1 add 333, column number 5 ignoring first frequency and add 333, column number 6 ignoring 2 first frequencies start from third frequency, add 2 to, okay, we have added. Now we go to the grouping table. This is the analysis table. See, here we got the highest number repetition 5 is the class of 30 to 39. Okay. Here 30 to 39, if we see, the frequency is 7. Now the frequency of the preceding class of the model class is 8. Here 8 is F0, 7 is F1. So in the formula, if we see F1 is 8, F0 is 7, what value we will get? -1. As I explained in previously, when there is a numerator or denominator comes minus, then you have to use the formula which ignores the mathematical symbols or signs. So here we have to use the formula mod F1 F0, ignoring the signs. Now here, what is F1 F0 F2? If you see here, F1 is the frequency of model 8, you remember, and if you see F0, frequency of the class preceding the model class, that is model class is 20 to 29, so 10 to 19. 4 is F0. Now coming to the F2, F2 is the frequency of the class succeeding the model class, that is 30 to 39, 7. So F1 4, F0 8, F2 7 coming to the formula. Here mode, okay, we have applied the formula, and the class interval is 10, okay, 10. Now here model class is 30 to 39, but we have taken 29.5. Why we have taken 29.5? Because the class intervals are in inclusive classes. Here we have to convert into exclusive classes. We need not convert all the classes into exclusive. Why? Because we are not taking all the classes for interpolation. We are taking only one class for interpretation. That is the reason if we compare the mean and here, mean will take all the values for applying the formula. Here we won't take all the formulas for applying the formula for interpolate the value from the model class. So how to convert the inclusive classes into exclusive classes? Already you learned. What is that? You have to take the difference between one class to another class. One class to another class means you can take any two side by side classes. Suppose in the third class 29 is the highest, in the fourth class 30 is the highest. What is the difference? 1 is the difference. Divided by 2, you will get 0.5. Then if you deduct 0.5 from the lower limit 29.5, add upper limit 39.5, you go to the next class here, 40 minus 0.5, 39.5, then there is a continuity, means exclusive class intervals. So here you have to deduct 0.5 from the lower limit 29.5, that is the L lower limit. So now apply the formula, you will get 34.1. Here you can note down the formula, which there is a different formula. That formula is L plus F2 divided by F0 plus F2 into I. You can also apply that formula and you can see there is a equal, sometimes a slight variation. Okay. In this formula, what I am just telling you L plus F2 divided by F0 plus F2. Here you can see F1 is missing. So F1 is missing because sometimes what will happen, the denominator may be 0 depending upon the data. Under such situation also either you apply this formula or what I told, that formula also you can apply. See, this is the when the numerator or denominators are 0 or negative values. Now you go to the third situation of the data. Now here inclusive classes, then the frequency, you go to the grouping table, then you go to the analysis table. Here you can see the peculiar situation. There are two values which repeated highest times, 5 and 5. Now we can take it as a model class. 80 to 90 is the model class and 90 to 99 is also the model class. This is a different set of data. So under this situation we can say that the mode is ill-defined, not properly defined. How in continuous series we can say mode is properly defined if we get only one model class. We are here, there is no possibility to get the one model class, so ill-defined. Under this situation, we have to see the empirical relationship between the mean and median, which are the family of measures of central tendency, family of mode. This family of mode you could understand if we draw the normal curve and draw the lines. If it is the positively skewed, because Venus is not in you, just I am telling for an additional knowledge, if the curve is positively skewed, then mode is mean is highest, median is in between the value of mean and mode is less value in the positively skewed data. In the negatively skewed data, mode is highest and mean is lowest, in between always median lies. So with that relationship, empirical relationship, mode can be interpolated by applying the formula 3 median minus 2 mean. So here you can calculate, because already you understand how to calculate the median, how to calculate the mean. You can take this data into consideration. You can calculate the mean. Verify yourself. The median is 83.84 and mean is 80.4. Then apply the formula. Then mode is 91.24. Now quickly coming to the another set of data. Some data by observing we can say the smooth data. What is the definition of smooth data? Smooth data means when the data shows more or less uniform movement, then it is termed as smooth data. Here you can see the data 3, 7, 15, 20, 15, 7, 3. Here, practical sense point of view, there is no need to go to the grouping table, apply the analysis table, then apply the formula. Simply the mode can be calculated. Upper limit of the highest frequency, lower limit of the highest frequency, means highest frequency can be taken as the model class, then model class higher upper limit and lower limit. Lower limit is 30 plus upper limit is 40 divided by 20 is equal to 35. You can calculate by, you can for your exercise point of view, you can do the grouping table and analysis table, you will get 35 mode. If the data set is like this, of equal symmetric, this data set, and you go to the final. This is the final data set in this session. This is the second instance. If you see, there is a slight difference, but it is the smooth. Under this also you can go to the another formula, that is mode is equal to LF0 plus UF2 divided by F0 plus F2, without using the grouping table and analysis table. Here the highest frequency is 20. This highest frequency classes are 30, 40. 30 is the lower limit, 40 is the upper limit. L is the lower limit. You see the formula presenting in the values, corresponding values. L is 30 into FO. What is FO? Frequency of the class of preceding model class. 20 to 30, 13 plus U is upper limit of the model class, 40 into what is F2? F2 is the frequency of the class preceding the model class. Model class is 30 to 40. So preceding the model class is succeeding the model class is 40 to 50. Its frequency is 16. Then FO plus F2, that is 13 plus 16. You calculate it, you will get the value 35.5. This is the mode, computation of mode in a continuous series. So thank you very much for patient listening and better understanding. Thank you.